So thank you for taking time to talk to us today, Shubham. So to begin with, can you tell us a little bit about yourself and your background?
Sure. I have graduated 2K15 from NIT Jamshedpur. I have worked in a couple of international companies like Works Applications, where I was data engineer for 3.5 years. I worked out of Singapore and Tokyo. Then I decided to join an early startup in India called ShareChat. It was really a small team, and they were just building the app. So when I joined ShareChat, it was about like 30 million daily active users that they got. When I left, it was around 160 million. So I saw the whole journey of how they scaled a social media company in India, especially for the Indian audience. Worked there, got an idea of how the massive amount of data gets generated, how it's sort of managed. Then I joined a company called PayPay, which was back in Tokyo. So PayPay was catering to almost half of the Japanese population with the like a fintech app, which is similar to like Paytm or some payment apps around the globe. So in there, like I designed a system which sort of you know it was managing the reconciliation of almost transactions of all the Japanese population that were generated on the apps. And then I sort of, because of the COVID and due to some reasons, I decided to stay back in India. And I then joined a company called Gamescraft. Gamescraft is one of the big, gaming companies in India. So I was a data engineering manager over there. So that's been my journey till now. I have been into industry for like almost 8.5 years now. Yep.
That is impressive. Like so many companies and so much varied experience, especially from that side of the world. So that is really interesting. Um, so can you tell me a little bit about your current startup and what prompted you to mm, establish this?
So I think one of the major motivations to start the current startup was, I have been a data engineer for almost last 8 years, and data engineering is the second toughest role in general to hire. It's one of the most expensive roles in terms of hiring, and the attrition in the industry is really huge. Average lifespan of data engineer in one of the companies is just like 1.5 years. So these were the major challenges. Although there were a lot of really great tools, great technologies around, but my motivation was to start DataZip is to basically create a low code, no code data engineering pipeline which can cater the requirements of mid-sized to early enterprise customers, which don't really have the time and the money to sort of hire a team of 2, 3 data engineers just to get started with your data journey. That was the main motivation, and that's why we started DataZip. Yeah.
That's awesome. And you have been using open source software in your company, right? Can you tell me a little bit about your experience in that?
Definitely. So we started DataZip as a product with four major components: data ingestion, data warehousing, data transformations, and then sort of visualizations as optional thing, and then one single monitoring and observability layer on top. So we have been actually the major component of this whole pipeline is ClickHouse, which is sort of like an engine of a car, kind of a say like in terms of data engineering pipelines, a warehouse or a lakehouse is sort of the engine of the pipeline. So we started working on ClickHouse because it has really great performance at ingestion, and also it has had a really great performance when you query, billions of rows. So we started with that. Soon enough, we realized, like ClickHouse is not sort of scalable. The open source version, at least, is not scalable. So we soon ran into some issues, and then now we are looking to, also work on that part and solve that part.
What are the scaling issues that you're facing with ClickHouse, and what are the alternatives that you're looking at?
So one of the major issues with ClickHouse is you can just scale it vertically as in, and also that requires some minimal amount of downtime
Can
because
you can you ex-
the
can you expand what do you mean by vertically?
vertical and horizontal means that vertical you can only increase the size of a single node machine. Horizontal means that it acts as a cluster and you can add more and more machines to scale it like infinitely, because vertically you have a certain limit in terms of hardware, right? You can only scale to, let's say, 1 terabyte of RAM, not more than that. But for horizontal things, it's sort of more flexible in terms of how you want to scale. And also one of the problems with that is if you don't want to have such a big amount of resource at place for a certain job or certain workflow, you horizontal scaling gives you a benefit of spinning up multiple clusters and adding more and shrinking that size of that cluster really flexibly.
Yeah,
That
you
was the
can
major
scale
reason.
up and down as you go, and also you can do with like commodity hardware. Scale up by just adding extra number of nodes versus very high performing CPUs tend to be very expensive. And to your earlier point, to your customer is mid and starting tier size customers probably can't afford that.
You're definitely right. So one of the main problems that we are facing right now is if you just keep on scaling up the machine, and sometimes let's say in the night somebody is not running anything, right? So you need to also scale it down. Now, if somebody just hits a query which is consuming a certain 64 GB RAM, then you're stuck. You have to wait for the machine to scale up again back to 64 or 128 GB and then run that query. That was one of the operating challenges with ClickHouse, at least as of now.
Okay, so what is the alternative?
There are a couple of alternatives. I found out, I was fortunate to figure out a project called Byconity, which I think Byte just sort of published as open source before a year or so. Other alternatives are something like a data bend. And also there are a couple of other alternatives like Apache Doris as well. Data bend and Doris, on the other hand, one problem with data bend is that it doesn't have a lot of open licenses when it comes to like openness and community contribution. So if you're working on data bend, you can't offer it as a certain part of data bend, you can't offer it as a managed service. And also for Apache Doris, they don't have a sort of storage and compute separated architecture as of now in their open source project. So Byconity has all of that. Like Byconity is open, it has the perfectly implemented storage and compute separation, and it also lets you spin up a virtual warehouses which you can use for specific use cases. For example, if you need one virtual warehouse for just your BI and analytical queries, you need one virtual warehouse for your data, some periodic data reconciliation jobs or something of that sort. You need one for your transformation jobs. So I think with that you can actually spin up individual VWs and shrink and scale up and scale down them as per your requirement. That's the best part about Byconity.
That's awesome. So I know you have run some tests with Byconity with already, right? Can you tell us a little bit more about the tests you did?
Yep. I think I majorly ran the tests via ClickBench. I mean, first test that I ran was in order to make sure that the data that we are ingesting directly goes through our S3 or some sort of Azure Blob Storage kind of a thing. So I performed it on Azure Blob Storage with Minio as a S3 layer in place, and then Byconity. So with that, what I can definitely say is Byconity is fully stateless. Uh, you can actually scale up and scale down the cluster really easily, and all of the data will be stored in S3. So that's basically quite cheap as well. None of the data is stored in the EBS volumes, which gets really expensive really quickly. That's the first basic test I sort of ran with Byconity over the Kubernetes. That was working really awesome. The second test that I ran was around the performance. Performance in terms of let's say ingestion as well as the reading performance. So and I ran it with the comparison with ClickHouse so that the test would actually resemble the exact scenario that we have right now. We are running right now ClickHouse as our data warehouse, but we sort of we are sort of doing some exploration in order to sort of offer that storage and compute separation layer, so that we are also testing out Byconity, how the performance of both of these technologies compare. So I compared standalone ClickHouse machine, like a single node ClickHouse machine, versus the Byconity performance. So I would say that I was really surprised to figure out this fact that the S3 based Byconity works as good as the ClickHouse, a similar size ClickHouse machine in terms of query scan or read performance, data scan performance. So that was one of the most surprising things. Like couple of limitations as well here. It's not like because Byconity is a really early project. So I would like to talk about a couple of limitations. The ingestion side of the things are slightly slower. In terms of actual numbers, the ingestion is you can like. get an idea, it's the ingestion that I did was around like 5 to 8 times slower. Just to give you some numbers, the query performance was exactly like, in some cases it was even better than ClickHouse. But for us, what matters is the query performance. Ingestion can be a little slower. That's fine with us because we are a near real time data analytics platform, not a really real time. And I think there are some options in Byconity as well in order to ingest your data in a real time using Kafka, but I did not test that.
Okay.
I ran a query with just a two sort of two pod virtual warehouse cluster. Then I wanted to check if the query performance goes up if I add one more pod to that cluster, virtual warehouse cluster. So I added one more pod, and then when I ran the query again on that particular pod, actually the performance increased. So that also shows that it's pretty easy to like just add the pods on Byconity because you know Byconity has a like separation of concerns when it comes down to reading and writing, but because it maintains writer virtual warehouses separately and reader, so you can add as many virtual warehouse for reading as well as you can add the pods in the individual warehouse if you want to sort of scale it up.
Awesome. Yeah, thank you. So, what are the next steps for you right now with?
So I think one of the next steps for us would be that we actually are planning to integrate Byconity by the mid of this year, around May or June. And we are actually planning to hire a couple of developers just for the sake of that. We also contribute to the Byconity as a community, and we also maintain it as a project, as well as we also get some things out of the Byconity, so that we can offer our customers the some benefits of the storage and compute separation and separation of concerns kind of architecture. So that's we are planning as of now. um, one or two more things as a roadblocks that I see, which I believe the community will solve going forward, is that one is like the currently the deduplication happens for a table size worth of 50 million, 100 million. I think that we as a community will have to solve in future because a lot of times customers want a table of let's say a billion rows till a billion rows to get deduplicated quite faster. And apart from that, other I think I would not say it as a roadblock, but I think one of the standardization of the backup and restore processes also what I see could be an improvement going forward. Once we start working on it, we can contribute to these areas as well as some documentation improvements as well. So that's where I see we as a team contributing to Byconity, and from Byconity we get an advantage of storage and compute separation and other benefits.
Oh, awesome. I mean, I want to really commend you. That's a really good open source behavior that I wish others displayed also. I mean, that's a true open source spirit. You use open source software and you contribute back to it. Uh, and every problem in open source is a community problem. I love that
Right.
attitude. Yeah. Somebody new to looking at data warehouse or Byconity or ClickHouse, is there anything that you would, any message that you would give to them? Maybe how to get started, or like, what are the things that they should consider?
I think one of the best things about Byconity is it's like fully open source and the Helm chart is also available. So I would definitely suggest the folks who are starting out, go to Byconity documentation and go to the Helm chart. You can run the Helm chart as it is like in a couple of minutes. What I would say is just spin up a 64 GB machine, run that, either run it on a sort of, a normal temporary local Kubernetes cluster, or you can also run it on a real Kubernetes cluster, and you'll be surprised. Like you'll be amazed to see the results and the actual storage and compute separated architecture. This is the first project which I see is fully open and it doesn't have any licensing restriction, and it has a really perfect storage and compute separation.
Awesome. Thank you. And I believe you will be writing a blog about your experiences as well, right?
Yes, so I'm going to publish the blog around the benchmarks or the ClickBench benchmarks that I did, in order to sort of give you exactly like how a 3264 GB ClickHouse machine compares with the Byconity.
Yeah, okay. So I guess the viewers can look forward to the blog as well. I'm really glad this is the power of open source. Because of open source, we're talking to each other today.
One thing I haven't mentioned, but usually like even though the community is still small right now, but Byconity team, the core team actually responds you on your tickets as well as the community. Where I faced a couple of problems when spinning up the cluster. So yeah, I think kudos to the team. Yeah.
Oh, awesome. Awesome. That's really good to know. So, for viewers' information, Shubham is actually sitting in India. I am in San Jose, and the Byconity team is in Singapore. So, we're really talking about a global team here in open source.
Yeah.
Thank you. Awesome.
Thank you, Sujata. Have a nice day.